Here they want you to write the following as an interval or the set of two intervals, which means you may have an or statement. No, part A is pretty easy because that's just an inequality written in set notation. So really not a big deal. It's the same thing as me as having said -7 less than x less than or equal to 5 without the fancy brackets or the x colon. So I start at -7. I'm not equal to it. I move up through 5 and I can actually equal that one. So there you go. B, I'm going to require to use, I have to solve. I'm going to solve this inequality. Now, I'm going to come up with a similar equation, get rid of the inequality symbol. I'm going to solve that equation. And when I solve the equation, do all the steps, clear the absolute value, add 3 to both sides, I get x equaling 8 or x equaling -2. Now these are the values that would make the left-hand side become 5, so I don't want that. So when I put them on the number line, I am going to use the open dots. I'm going to choose numbers from each of the three regions I have. I chose -3, 0, and 9. And I show that those numbers didn't work, that the numbers didn't work at the two ends, they worked in between. Now, if you remember anything from your high school algebra, you usually saw that less thans became ands statements, and and statements are usually the ones that have two endpoints and a shaded part in between. So, but I see this here, and I don't have to worry about making an and or an or statement. All I have to do is say, okay, well, interval notation, that's going to be -2 to 8. Or I could say -2 is less than x, which is less than 8. Same thing, that's the answer. So, interval notation is usually the way we go, but make sure you know how to translate from it as well. Again, you could have the x here's an instance where you might want to have that x in front with the element e, because -2 comma 8 with parentheses around could be mistaken for an ordered pair. Now, if you look at the context of the problem, you should pretty much know, well, it probably isn't, because this represents a solution to x, doesn't represent a coordinate on a x and y plane. Same thing with this one here. I solve a similar equation and get the solutions of 4 and -8 as the answers if I solve the equation. Now, those values would make the left-hand side of the original inequality equal to 6. So, and here I'm allowed to equal 6 because of the equal to sign on that greater than symbol. So when I put them on the number line, I'm going to have closed dots there. And again, I'm going to pick some values that are to the left of -8, between -8 and 4, and more than 4. So I use -9, I use 0, and I use 5. And when I use -9, it works. When I use 0, it doesn't work for the original inequality. Because remember, I'm looking for a value that's greater than or equal to 6. And when I choose 5, it works. So the two ends I shade in, and the middle part is left as a gap, which is typical of an or statement. And if you remember anything from the rules you learned about in algebra, if I have a greater than or equal to symbol with this absolute value, it was always going to be an or statement. But again, if you didn't remember that, the number line would tell you. So here I would write it as this in interval notation. Again, when I see a gap between two shaded regions, it means it's an or I use this union symbol, but basically just means, hey, I have a gap here. And of course, I go from -infinity to -8, can't equal -infinity either. Square bracket on -8, square bracket on the 4, comma, infinity symbol, and open parenthesis or close parenthesis. Again, the union symbol in between indicates there's a gap where there's values in between -8 and 4 that do not satisfy this inequality. Here they're giving us multiple intervals that have some degree of overlap, and they want us to write it as a single interval. And how you would do that depends on, whether you're doing a union, which you see for the first two, or if you have an intersection, which you see in C and D. A union is like an or statement. An intersection is an and statement. So in each one of these, I'm going to look at some number lines. For A, for instance, I put the numbers down of consequence, the ones I see mentioned, -4, 2, 7, and 11. And here's what the two intervals are telling me. I go from -4 to 7, not including the 7. I go from 2 to 11. we want to write this as a single interval. So since it is an or statement, when I start writing the actual interval on the number line, anywhere I see a line above it, I'm going to shade the number line. Now, if I see two lines above it, doesn't matter. I'm still going to shade. As long as there's at least one line above that part of the number line, it's going to get shaded. Along with that, some people want to try to preserve the whole at 7. The fact of the matter is, yeah, for the first interval, your variable, whatever it is here, couldn't be 7. But for the second interval, it can be. 7 is between 2 and 11. So anywhere I see at least one line above it, I'm shading it. And when I shade it, I have an interval on my number line that goes from -4 to 11, including those two endpoints. And therefore, that's my interval, -4 to 11. Close brackets on both ends. For B, same kind of thing. I can't put negative infinity on the number line. I can put the -1, 8, and 15 I see there. And again, I'm gonna draw out the intervals I have. I have the one that goes from negative infinity to 8. I have that one on top. And I have the one that goes from -1 to 15 on the bottom. The one that doesn't include -1 but includes 15. And again, since this is a union, anywhere on the number line that I see these two other number lines, at least one of them floating above it, I'm going to shade. Again, a lot of students think, well, I'm going to try to preserve that whole at -1. Well, no, because the first interval, whatever variable you're using here, can equal -1 because -1 is between the interval from negative infinity to 8. For C and D, I'm going to be doing the same number lines, have the same starting graph as I did for C. The other thing that's different here is I have the intersection symbol, which means that I have to satisfy both original intervals, and only the parts that satisfy both are included. So intersections tend to be a little bit more exclusionary, whereas a union is kind of more inclusionary. So as far as part C goes with the intersection, I only want portions where I have two lines above it, or two values above it that that each one of these intervals share. So here's what I'm looking for the first one, between 2 and 7. Kind of off a little bit. I don't know why I went off when I did this PowerPoint and changed it over and everything, but I don't include the 7 because 7 is not included in both intervals. So that's really what the AND one. The AND says, well, both, or if there's more than one, they all have to be considered. They all have to be taken, into consideration. Whereas for D, same two originals, but again, I only want where these two other number lines overlap each other. So that's between these two regions, and that goes from -1 to 8. Not including -1, including the 8. There's your interval symbols and stuff like that. So there those are.